So regarding the control sources, so of course you should build control sources using the nonlinear devices, and of course you have BJT and MOSFET, and in BJT you have two types, NPN and PNP, and in MOS of course you have another two types, NMOS and PMOS, right? So it is, you can always look at things for one device and extend it for all other devices. That's the way I've taught you all the things, and you can also build on top of that. So I will be teaching you with respect to NMOS transistor. You can always extend it for NPN or PNP or PMOS or whatever. Okay, it's very straightforward, because how each and every device is interlinked and they are one and the same, just the equations are different and the potentials are different. That's it, nothing else. Okay, so let's take for example the NMOS transistor for all our control sources. So we'll be building control sources using NMOS transistors. Okay, so as far as an NMOS transistor is concerned, you have drain, source, gate, and the incremental equivalent is something like this: VGS here and GM VGS. This is drain. Okay, this is gate, this is source. All right, this is what I have. Now I have to build my control sources using this NMOS transistor. So first of all, as I said, in order to have a negative feedback, first what you have to do is to sense your difference between desired and actual. This is what the first step, and the second step is you control the output in a way to reduce the difference, right? We know this. Now as far as the first step is concerned, you have to sense the difference between desired and actual, and I said that you will be doing it at the input side. Okay, you will compare the input voltage and some fraction of the output voltage. So these desired and actual will be compared on the input side. So on the input side, what you can actually compare two voltages only. As far as the MOS transistor is concerned, you can only compare in the form of voltages, right? And it is nothing but your gate and the source terminal forms the input. So as far as the sensing or comparing or sensing is concerned, you can do only at the gate or source terminal at the input. Okay, sense or compare. So it's very similar to what we did in the DC feedback. Okay, I'm just repeating it for your convenience. And controlling the output in a to reduce the difference is the output is output current here, and it can be controlled either at the drain or the source terminal, because these two terminals consisting the output. So you have drain or source terminal at the output for control. Okay, these are the things that you have, and with this idea of sensing at the input side and sensing the difference at the input side and comparing or controlling things at the output side, you are going to construct control sources. So what are all the control sources? Obviously you can sense the current from here and control things on the input side. I mean, like, you can you can actually provide some kind of input voltage and then make it act as a current source, or you can provide some input voltage and make it act as a voltage source, or provide some input current and make it act as a current source, and provide some input current and make it act as a voltage source. Okay, so in this way you can construct what are called voltage control voltage source, voltage control current source, and current control voltage source, current control current source. Okay, these are the four sources that you can actually construct with this MOSFET, and not only MOSFET, using BJT also. And we'll see each of these things in the next few lectures, so that we'll have a complete idea of what exactly these control sources are and how they are supposed to be constructed and all these things. Before going into that, let me give an important information about the property of control sources essentially. For example, if you take a voltage control voltage source for that matter, it means that I give some kind of input voltage, and this voltage will control my output voltage. That is what it means. This voltage will give me some kind of a output voltage. For example, if I give some V1 at the input, and then I say that I give it to a resistor, another resistor here. Okay, so say this is R1 and R2, and if I try to see what is my voltage across R2, say for example this is V0, say, then I would get V0 is equal to V1 times R2 by R1 plus R2. Okay, so essentially what is happening, if I take this and connect it to some other terminal or some other circuit, that will be driven by this voltage V0. That would mean that for example, this is a voltage source, or rather this is the output voltage that I am actually achieving, which is being controlled by the input voltage V1. Just that here there is attenuation, but it's still a voltage V1 that is controlling another voltage V0. Okay, so but then can we call it as voltage control voltage source? Okay, but we really cannot call it as voltage control voltage source. This has a separate property. First of all, if you want to have a voltage control voltage source, you should satisfy those properties, or rather all the control sources should satisfy those properties that are related to the input impedance and output impedance. Okay, here I am writing in terms of resistance, input resistance and output resistance, but you can always generalize to the case of input impedance and output impedance. Okay, so this is just an example to show that you can always have a case where another voltage, one voltage here is controlled by another voltage, but you cannot call it as voltage control. This V1 is controlling this V0. Of course it is true, but then it doesn't mean that it is a voltage control voltage source. Meaning, if it has to be a voltage control voltage source, then the first thing is the control side that you are talking about. Say for example, let me put it here. Okay, say I have a port here, and then I am going to control the second port here. Okay, this is let's say this is 1 and 1 dash, and this is 2 and 2 dash. Okay, and I want to control the second port using the first port voltage, let's say like this. Okay, and let me connect my voltage source. So it will always accompany with a RS source resistance, because nothing is ideal. So I have some kind of a VS, okay, source voltage. So I have connected that to the first port. Now this port might have some input impedance, and what do we mean by that? We have seen that as long as the port is concerned, you take a cut line, and then before connecting anything, okay, this is external connection. As far as this particular port is concerned, port 1 is concerned, this two lines construct a port. Okay, and to the left of this line, whatever we connected is external, and we look inside the port, and whatever you see as a resistance, it's an input resistance. Okay, similarly on the output port, there can be something here. Okay, and you can connect anything at the output side, but then I look from here into this, on the left of this line, and whatever I see as the resistance, it's the output resistance. This much we know already. Okay, And voltage control voltage source essentially means that I have port 1 whose voltage, difference voltage, this one, let's say VD, will control the second port with some gain, say A times VD. Okay, this is what voltage control voltage source is. And in this case, what happens, if suppose I have an input impedance, say I have a resistance here, okay, looking in, I have a resistance here, means say R, my input impedance equal to R. Okay, so what does it mean? It means that some part of this voltage Vs will drop in this R. That means this voltage between these two terminals, okay, is not entirely this Vs, but that is what I have connected. I want all the voltage that I have given here to appear here, because I always want no loss in the circuit. Okay, but what happens, because I have some kind of an input impedance, this is the control quantity. This voltage, this input side, I am constructing a voltage control voltage source. Okay, and this is the controlling quantity. Voltage here is the controlling quantity, and that itself is getting attenuated here, means that is not good. I want all of this voltage to appear here to control the second port. Okay, and that is possible only when this R is tending to infinity. Then only this side will be open and no current will flow. All the Vs will appear here. So for a voltage control voltage source, the input impedance should be infinity. In other words, if there is a voltage controlled quantity, if the input port is being controlled by the voltage, I should see infinite input impedance. Then only all the voltage will appear here. Okay, so wherever you have voltage as a controlling quantity, I should have an input impedance of infinite input impedance. Okay, similarly on the output side, by now you would have guessed, I want all of this voltage. If basically this is a voltage source, right? If it is a voltage source, I want the voltage source to be as ideal as possible. Now I have this RS. I am saying this RS as the source resistance, because nothing in reality is ideal. And then I always have this source resistance associated with this, and I want this source resistance to be as minimum as possible. Now this is going to act as a voltage source to control something else, right? So when this is acting as voltage source, and the resistance that is going to be associated with this voltage source should be as minimum as possible. Say for example, I have output resistance R out or not, okay, and I am going to connect an external circuitry of RL here. Now what happens, if I want this all the voltage to drop across RL, I want this R0 ideally to be very very small, or not to be 0 approximately. Okay, and then only I'll have my output impedance to be 0, and if only I have this, all the voltage will drop across RL, okay, or all the voltage will appear across RL. So for voltage control voltage source, R out should be 0, or any on the output side, if anything is going to act as a voltage source for me, I should have a 0 output impedance. So the voltage source quantities will have 0 output impedance, and current source quantities, you would have guessed, should have infinite output impedance, going by the same logic. Because on the current, if it is going to be a current source, then I will have output impedance occurring parallel across it, but that is how the source should be. So I want this to be infinite, so that all the current will flow through some load resistance that I have. So similarly on the control, on the control side, current source should have, say for example on the control side, if I have a current source at the input, that will accompany with a parallel resistance, and I don't want any current to flow into this. All the current I want to flow only to the whatever I am being, rather let me draw it here. If it is going to be a current control port, say I have port 1 and 1 dash here, I am going to connect a current source, then I will have a situation like this, okay, with a parallel RS. Now I don't want any of the current to flow through, say IN I don't want any of the IN to flow through RS. I want all of it to flow through the input side, so that I can control, say this is the current that I want, okay, say this is the I current, which will be controlling, say if it is a current control current source, that is going to control my say some A times I will control my current source here, and that will essentially have some kind of a source resistance here, okay, and at the output this is like this. Now I want all of this current to flow here through this I. Okay, it is only possible when there is a short here. Then only all the current will flow here and I will be equal to I in, and that will exactly control this particular current source. Okay, so as far as the input impedance is concerned, for a current controlled side, okay, so if it is current is going to be the input side, which is the controlling quantity, then I want the input impedance to be 0, right? Then only it will act as a short. So current control side input impedance should be 0. And as I said, if the control source is going to be a current, then this resistance, ideally I want it to be infinite. Then only if I connect RL here, all of this current will flow through RL. Okay, so this resistance is the R out, which I want it to be infinite. Then only it will be open. So that's how we construct this property. And any control source that you mention should satisfy this property accordingly. It should have R in and R out accordingly. So whatever control source we are trying to construct, we'll verify this property for those control sources. Okay.